Alrighty, grade 8s, welcome to a new math video tonight. We are dealing with 4.2, creating objects from nets. I got something cool I want to show you here. This one right here. Take a look at this. This is our lesson right here. What do you see when you look at it? I see two things. I see pentagons, 1, 2, 3, 4, 5. And I see hexagons, 1, 2, 3, 4, 5, 6. So I see a bunch of white hexagons and a bunch of black pentagons. Well, what's our lesson? If we go back here, remember our lesson we said was creating objects from nets. So guess what? This right here is a net. What is it a net of? Well, if we were to cut it out and fold it up and tape it up, and in this case, blow it up with air, it would actually form a soccer ball. So believe it or not, an everyday object, when you guys play with a lot at recess, is a great example of a net turning into a not everyday object that we use. So there you go. That's it. All we're going to do today is look at nets and see if they would, or what we think are nets, and if we could fold them up, would it form a three-dimensional object? Okay, that's as simple as the lesson is today. So we're going to go right here, straight to it. Take a look at this object right here. The question is this shape that is hopefully going to appear right away, is it an example of a net? Well, here it is. If we were to cut this object out and fold it along all these lines, would it form a three-dimensional shape? Now, a net actually, let's go back here for half a second. A net, if something is a net, it actually has a top and bottom to it. So this right here, the shape, if we were to fold it, you have to imagine, but there's no single overlap right here. And since there's no overlap, that means there wouldn't be anything to close the top off here. So this is an example of something that is, it's what we'd call not a net. That is not a net. All right. It is not a net for a rectangular prism. If this diagram is folded, it would form a box that is open at one end, and at the opposite end, two rectangles would overlap. Okay. Well, let's practice a bit here. There's four shapes here. Okay, let's look at this shape. Now you got to use your imagination. What do I see? A bunch of rectangles, 1, 2, 3, 4, 5, and then two congruent shapes. 1, 2, 3, 4, 5 pentagon, two congruent pentagons. So now I got to imagine. Okay, if I folded this up, this would be my base. This would come up and form a side. That form a side, 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 side. So I'd have a base with the walls, and then this flap would fold over along this line and form the top. So guess what? That is an example of a pentagonal prism. Cool. Let's look at B here. Picture it for a second. If you cut it out and you folded it up, right off the bat it looks a little wonky because of this side right here. But don't let that fool you. This would fold up, this would fold up, this side would fold up, and then what would happen is we'd fold it here, and that would come over and attach to this base. So this is an example of a pyramid. In this case, it would be a rectangular pyramid. All right, moving on. C. Well, this is tougher. What do we got here? We got a bunch of rectangles surrounded by two identical triangles. So remember, from a previous video, if you have two congruent shapes, those will form the base, and that is the name for our prism. So we know we're dealing with a prism, and it's a three-sided shape, so it is a triangular prism. Now if I folded this up, that would be along there, along there, and along there, and then this would fold over and make the top, and it would close it off. So this would be an example of a triangular prism. D. Look at this one. This looks peculiar, just like this one up here. It kind of looks off, just like this one looked off. But remember, this one worked out. So now I'm really going to test your visual learning here. Okay, so I have a bunch of triangles surrounding one base, one shape. So right off the bat, this tells me if anything, it's going to be a pyramid, and it'll be a 1, 2, 3, 4, 5, 6, 7, 8. It'll be an octagonal pyramid. All right, so if this side folded up, oh, right here something's wrong. You see if this side folded up and this side folded up, this triangle and this triangle here would actually overlap on this side, and we can't have that. Or if it does that, it's just not considered a net. And then what I noticed is over here, if this side folded up and this side folded up, there's nothing in between here. So there'd be an open gap. So D here is an example of not a net. What would I change to make it a net? It could be something as simple as this overlap we'd have to get rid of, so it doesn't matter. You can take either one of these. I'll take this one right here. And I would take it off, and now I'd add it to this shape, but does it matter what side I add it to? If I added it to this line and folded it up, guess what? It would overlap with this one. So I can add it to this side. But you know what I could do is take it, add it to this side, because it wouldn't overlap with this one, and it would have a base there. And then that would be an example of an octagonal pyramid. That, folks, is our lesson today. That's as simple as it gets. We're just going to basically, when you show up for class tomorrow, we're just going to play around, bring some scissors, we're going to have some paper, we're just going to cut out a bunch of nets and see if they actually form together to make a three-dimensional object. All right, so I will see you in class tomorrow. No question today, just have fun. Bring some scissors, please. Bring some from home. Bye for now. Catch you tomorrow.